Okay, hi everyone, I am Madam Rosmaya. So in this video, we are going to discuss on tutorial 5. Okay, this is the first question. So let us read the question. A ball is thrown with a speed of u at an angle of theta to the horizontal. Draw on the same diagram the trajectory of the ball when the angle theta is 30 degrees, 45 degrees, and C 60 degrees. Okay, so we draw the Cartesian plane. Y-axis is S and x-axis is T. And don't forget to write the origin here as 0. Okay, so at 30 degrees, so you label it with A. And for 45 degrees, the curve, the parabolic curve must be larger than the 30 degrees. And then for 60 degrees, we draw the same uh, range here, okay, same range as A, and the peak here is larger than A, because here you can see the relationship between the two angles here. 30 degrees plus 60 degrees is 90 degrees. So that's why the parabolic curve here, the range are equals. Okay, so next we go to question 2. Okay, three projectiles are launched with different speed, but they have the same range and time of flight as shown in the figure. So compare the horizontal components of velocity and then the initial vertical components of velocity and the speeds of projection of the projectiles. So give reason for your answers. Okay, so we do question A first. And remember that the question said uh, all of the projectile here have same range and same time. So they reach here at the same time. Time taken is the same. Okay, so now we go to question A first. Compare the horizontal components of velocity. Okay, so the horizontal components of velocity, the velocity of the projectile here is when we draw at the point on the projectile, the direction is tangent to the curve, right? Tangent to the parabolic curve, like this one, and the last one here for C, A, B, C. Okay, so the component will be ux, okay, and the range is r, okay, and we are going to compare the ux for A, ux for B, and ux for C. Okay, that's the question asked. Compare the horizontal components of velocity. Okay, then the time taken is t. Okay, and all these projectiles have same r and same t. Okay, now from here we can calculate r. So the r is equals to the ux times t. We choose the horizontal component. R is in horizontal. R is already in horizontal. So the component of speed times time, we will use horizontal speed. And then the time taken is a scalar. So you just, it doesn't have direction. X, tx or ty, just t. Okay. So we rearrange the equation here. We get ux equals to r over t. Okay, now r is constant, okay, like mentioned in the question, and then t also constant, mentioned in the question. So therefore the ux will give you a constant value. Okay, so that's mean ux for A is equals to ux for B, and also is equals to ux for C. Okay, that's the question, the answer for question A. Okay, next we go for question B, the initial vertical components of velocity. Okay, this time the vertical component, just now the x component. Okay, so the time taken still the same, t, and at the peak here, the time taken will be half of t. Okay, because this is projectile, so the shape is symmetrical. That's why the time taken to reach the peak will be half t. Okay, then let's say the height is h. Okay, and we using the linear equation v squared equals to u squared plus 2as. So we take the vertical component because here we are going to compare the vertical component, initial vertical component. That's why we choose the y component. So vy squared equals to uy squared minus 2gs. A is negative g because is in the direction, the motion is upward against the g direction. Okay, so at the peak here, the vy component will be 0. Okay, and at initial, the speed is uy, or the velocity is uy. This is what we are going to find, the initial vertical components of velocity, which is uy. Okay, minus 2g, and then the height reached by the projectile here is h. Okay, then we rearrange the equation, we get uy squared equals to 2gh. Okay, so compare the h of projectile A, B, and C. So the h A will be is less than hb and less than hc. So therefore, from g is constant. So when you see the relationship here, the higher the h, the higher the or initial vertical component of the velocity. So we can write as, okay, uy for projectile A is less than uy for projectile B, and is less for uy projectile C. Okay, because they are directly proportional. Uy squared is directly proportional to h. Okay, so therefore uya less than uyb and less than uyc. Okay, so this is the answer for the initial vertical components of velocity. Okay, next we go to question C. Okay, compare the speeds of projection of the projectiles. So the speed of projection of the projectiles, this time it doesn't mention the component. So that's mean the direction of the speed is tangent to the point. So which is from the Pythagoras theorem. Okay, so u squared is equals to ux squared plus uy squared. Okay, so we calculated already uxa, which is equals to uxb and equals to uxc and equals to ux in the question A just now. So they are all equal, so we put as ux. Okay, so this ux is a constant. Okay, then the uy we get from question answer from B just now, where uy for A is less than uy for B and is less than uy for C. Now refer to this equation. Okay, compare these two equations. So this is the u and ux, uy. So that's why we use Pythagoras theorem. Okay, so u squared equals to ux squared plus uy squared. Okay, then we compare these two. Okay, so uy for A less, right? Less. So that's mean you will get the UA also less. So UA less than UB less than UC. Okay, because UA here less, so this U also less. Okay, because from the relationship here. Okay, compare these two. Okay, so now we've answered the question C. Next, we go to question 3. A ball is thrown with a velocity of u at an angle of theta to the horizontal. Find the maximum height reached by the ball in terms of u, theta, and g. And then question B, at what angle should the ball be thrown so that the maximum height reached is the same as its horizontal range? So we do question A first. So the maximum height reached by the ball in terms of u, theta, and g. Okay, so let's say this is the u. initial velocity. So the angle made to the horizontal is theta. So the maximum height is here. Okay. And then at the peak here, it is understood that Vy equals to 0. Okay, then the component of vertical component for you is u sine theta. Okay, so now we choose all the vertical component, u sine theta, h, and then Vy. So we can find the maximum height using Voise. Okay, so this is the linear, one of the linear equation from the 3 linear equation. Okay, so at the peak, Vy is 0, and then the Uy is u sine theta, and then the A is negative G, and then the S is H. So we simplify this to get maximum height. So we put H as a subject here. Okay, we arrange the equation, and we get H equals to bracket u sine theta squared over 2G. Okay, so this is the answer. Okay, all is in the terms asked by the question already, u, theta, and g. So look at here, u, theta, and g. Okay, so next we go to question 3b. Okay, at what angle should the ball be thrown so that the maximum height reached is the same as its horizontal range? Okay, so now the question said that maximum height same as the horizontal range. So maximum height, just now we get bracket u sine theta squared over 2g. So the h here is equals to the horizontal range is r, right? Horizontal range is r. So they are equal. This is mentioned in the question, r equals to h. So we equate them. Okay, for r, we can use horizontal component because r is in horizontal. So horizontal component will be r equals to u cos theta times t. So the g is 0. So we just use r equals to u cos theta times t. Speed times time for horizontal component. Okay, now we for t value, okay, we can use the linear equation s equals to ut plus half at squared. So sy when reach the ground is 0. Okay, at this point 0. So for time taken, we take the vertical component. So sy at the other end will be 0. Okay, so u is u sine theta, and then t, the time reach here, plus half negative g because the motion is upward, and then t squared. So we get t here. Factorize the equation here. We factor out t, bracket u sine theta minus half gt. Okay, so t squared here. So t times t squared. So we factorize t, factor out t. So bracket, we get this, and we get two values. We use the factorization method. So t equals to 0. Another t will be 2u sine theta over g. So t0 is at the starting point here. And then another t, 2u sine theta over g is when the ball reach on the other side. When reach the ground again here. Okay, projected here and then reach the ground here. So this is the time taken. Okay, so this time we can substitute into here. So we substitute this t into here. Okay, this t into here. Okay, next we equate this r to this h. Okay, so now these two we equate. R equals to h. Okay, so r is u cos theta to u sine theta g, and then equals to h. H is bracket u sine theta squared over 2g. Okay, so we simplify this equation to get the angle theta. Okay, so we cancel sine theta. One of the sine theta, we cancel out u. And then because this is u times u squared. So left side, right side also u squared. And then we cancel out g. So we cross multiply cos theta to here, sin theta over cos theta, and then 2 times 2 is 4. So sin over cos is tangent theta, and therefore theta is 76 degrees. Okay, you can round it off to 76 degrees. Okay, that's the answer. Okay, simple, right? Okay, next we go to question 4. Okay, when a rifle is fired horizontally at a target P here, okay, on a screen at a range of 50 meter, so the range given here 50 meter, the bullet strikes the screen at a point 20 millimeter below P. So this is the target point. Okay, the screen is now moved to a distance 100 meter. So the distance double, 50 meter to 100 meter. So the rifle is fired again horizontally at P in its new position. So the new position is here, okay, the second position. Okay, so the question is, assuming that air resistance may be neglected, what is the new distance below P at which the screen would now be struck? So this is first position, is struck here, and then the second position, so we don't know where the position is. So this is where we are going to find. Okay, so how to do? We divide into two parts. Okay, so this is the projectile. Okay, projectile motion of the bullet. The bullet. Okay, so the first is strike here. So we take the first strike first. The first strike. So we use S equals to UT plus half AT squared. So we choose a vertical component because 20 millimeter here is vertical. So we choose vertical component, 20 millimeter, convert to meter, and then the initial velocity is U. U times no okay correct the U 0 plus half G T squared. Okay, so we solve the equation here to get T. Okay, so the time taken from here to here is T. And then this is equation 1 because we actually we can find T first, but let's say this is equation 1. And then for here, for the second position, when we move here, so the velocity of the second one, we don't know the S prime, so we just put as the distance vertical distance just now 20 millimeter, but for the second position we don't know, so we just put as S prime, so equals to, so initial velocity for Y component will be 0, okay, because at this point the vertical component of velocity is 0, okay. So is 0 plus half G is positive because the motion is downward, same direction as the G. Okay, then the time taken to reach here it is understood to be 2t. Okay, double the t because the distance travel 50, so this one is 100. So when you double the distance, so the time taken also double. So that means t becomes 2t. So this is equation 2. So look at here, 50, 100. So that's why you know time taken is 2t. Okay, so now you solve you get t from the equation 1, then you substitute into here. Okay, so from these two equation, so this is 2gt, okay. 2 times 2 is 4 divided by 2 is 2, okay. So we get 2gt squared, and bring 2 to the right side, so half S prime. Okay, then this gt from equation 1 here, we cross multiply, so the 2 here times 20, so gt squared, this is gt squared, right? So this gt squared, the 2 here we cross multiply, so you substitute into here, so we get the answer S prime equals to 80.0 times 10 to the power of negative 3 meter. Okay, or you can write in the millimeter as 80 millimeter, because this is negative 3, so 0.20 millimeter, right? So 80 millimeter. Okay, so you can use another method. Okay, another method you will get the same answer. Okay, so just now 20 millimeter first position, and then when 100 meter range, we don't know the S, this S, or we can put S or S prime. Okay, so the time taken T1, the time taken for to reach the second target is T2. Okay, S equals to UT plus half AT squared, so we still use the same equation, S equals to UT plus half AT squared. So you substitute the S here. Okay, I use H, H, S also can, but I use here H. Okay, so 0 times T1, time taken here for the first target, half GT1 squared. Okay, so you substitute this value, but T1 you don't know. The G is 9.81. So T1 you can use 50 meter here. So the horizontal component, okay, you can use this method. So R equals to UX times T1, okay, horizontal component. So the range is 50, and then you must use initial velocity component, X component, and then times the T1. So you get T1 equals to R over UX. So you can substitute this into here. Okay, so R is 50 over 2x. Okay, so you substitute into here, so you get this value. Don't forget the square. Okay, so you get, you rearrange the equation, you get the UX 783.02 meter. So we haven't come to the final question. For the question asked for S, so we don't round it off yet. Okay. So we do the same for next target, okay, the 100-meter target. So the S we don't know, equals to half 9.81, but TU, this time TU is 100 over UX. So the range now becomes 100 divided by UX. UX is the same because this is the same projectile. Okay, same projectile. So you can use UX. Okay, so you substitute the UX just now into here, and you get S equals to 0.08 meter. So same answer like just now. In millimeter, so it's 80 millimeter. Okay, you can answer it in meter, or to compare with this 20 millimeter, so you can convert it to 80 millimeter. Okay, so same answer. It's up to you to use which solution. Okay. Okay, so um, so remember the four uh, four kinds of projectile problems. Remember to use linear equations. Okay, what was suited, and then to choose the correct component, horizontal component or vertical component, and then don't forget the sign for G or S, whether it's positive or negative. So depends on the projectile motion. Okay, so the first projectile here is G is negative and S is positive, because the reference point always refer from the origin here. So this is on the positive side. Okay, for here also positive G, positive S. For this kind of projectile, the G is negative, so the S can be positive and can be negative, because on the top here the S will be positive, and at the bottom here the S is negative. And lastly, this kind of projectile, the G is negative and the S is positive because it's above the origin. Okay, so next we go to question 5. Okay, we read the question. A ball is thrown horizontally with a velocity of 20 meter per second from a cliff. Assuming that air resistance may be neglected, what is the speed of the ball 5 seconds later? Okay, so imagine this is a ball thrown horizontally. So U equals to 20 meter per second. So this is horizontal U. So it is understood that vertical U is 0 because the ball is thrown horizontally. So the vertical U is 0. Okay, then 5 second later, that means somewhere here, we don't know, we are going to find the speed. So horizontal component of the speed is always the same. So the u x will be 20 meter per second, but we don't know the uy. So time taken 5 second. So the speed, this speed is tangent direction or is tangent to the point on the curve here, the projectile curve. Okay, so we just need to find Vy. So Vx, you know, it is equals to U. Vy, that one thing that we are going to find before we find this V, where we can use Pythagoras theorem. Okay, so to find Vy, we can use V equals to U plus 80, and we choose the vertical component. Okay, so vertical component for u, y will be 0 because it is projected horizontally. So the uy is understood to be 0. Okay, and then a is negative 9.81. Okay, the a is positive because it's downward motion. So it's positive. This one and the t is 5 second. 5 second. So you get Vy, actually this is supposed to be positive. So Vy is 49.05 meter per second. Okay, wrong sign here. This one supposed to be positive. Okay, so I use pen here. Okay, so this one is positive because downward motion. Okay, so I go back with the uh, point here. Okay, so make that correction. Okay, so now Vy is 49.05. So we can use Pythagoras theorem to find the V, where V is Vx squared as V squared is equals to 20 squared plus 49.05 squared. Okay, use Pythagoras theorem, so we get V 52.97 meter per second. Okay, but this speed is a vector, so you need to find the angle. So the angle for the direction, the angle here we can use tangent. Tangent theta is opposite over adjacent. So 49.05 over 20. So you get theta equals to 68 degrees. Okay. So two significant features. This is 53 meter per second, and here you write as 68, 68 degrees. Okay, so don't write in four significant features. So you follow the number of significant features given in the question. Okay, done for 5. Then we go for question 6, the last question for tutorial 5. Okay, a bomb is released from a plane which is diving at an angle of 30 degrees from the vertical. So the plane is at a height of 1000 meter when the bomb is released. So the bomb hits the ground 10 seconds later. What is the speed of the plane when the bomb is released? So the G we use is 9.81 meter per second. Okay, so diagram is not given, but you can imagine like this. So the angle made is 30 degrees to the from the vertical. So look at the question, 30 degrees from the vertical. So this is the where the angle is. So we are going to find the speed of the plane when the bomb is released. So the speed of the angle is in this direction. In this direction. So this is what we are going to find, the U. Okay, so look at this diagram. The component of U is U cos 30 degrees and U sin 30 degrees. So it depends where the angles given is. So from the 30 degrees here, use the trigonometric ratio. So we get here U cos 30 degrees and here is U sin 30 degrees. Okay, so the distance is 1000 meter and the time taken 10 seconds to reach the ground. Okay, so we can use SUTAT to find the U here. Okay, and we choose vertical component because 1000 meter is vertical, right? So we choose vertical component. So S is 1000. So the U, you must choose U cos 30 degrees because vertical component is U cos 30 degrees. It's not U sin 30 degrees. U sin 30 degrees is horizontal. So we choose U cos 30 degrees. in the vertical component, and then time taken 10 second, and then plus half g, plus because it downward motion, so same direction as g, so the g is positive. Okay, again here time taken 10 squared, so you get u 59 meter per second. So u is already in the direction of the plane, so the answer is 59 meter per second. Okay, so that's all for the tutorial 5. So I hope you all can understand, and bye bye.